Hello everyone. Today we learn about the chain rule of partial derivatives. Yes. Okay. So let's first revise the chain rule for a single variable case. So what was that? Say we have a function f of x and this x is a function of t. So our f is a function of x and x is a function of t. So if we take the derivative of this is a composite function. So if we take the derivative of this would just be dx dt. This is the single variable case. So now what if we are dealing with a function of two variables, let's say f of x and y, and x and y is a function of t. In many physical scenarios this would be the case because position, the x and y position, can be a function of time t. So what shall we do in this case? In this case, the chain rule of partial derivatives say that we have to do the following. dt, which is we take a partial derivative with respect to x and x with respect to t, again y and y with respect to t. This is the chain rule of partial derivatives. You can expand this to an n variable case. I'll show it after the example. Let's see an example first. So say our x is a function of t and we have 1 plus at, and y is a function of t which is b cubed, and the function we are asked to differentiate is x exponential minus y. So what shall we do here? So what would this be? Let's apply this. So let's first, what would delta f over delta x be, or partial f with respect to x? This is just right, and what is, because I took the derivative of this, what is this? This would be just a plus, what about this? This would be, we would pick up a negative sign because of the negative in the exponential. We would get, and from the second term, from this we would get 3bt squared. Yeah, did we miss anything? Yes, oh, yeah, I missed an x. There should be an x. So now let's just plug in our x and y, with x and y, which is a function of t. This y is bt cubed, a minus x is 1 plus at, 3bt squared, and exponential So you can write it by factoring out the exponential term. So if we factor out the exponential term, we are left with a minus 3 pt squared minus 3 pat cubed. So this is an example of chain rule, which is for a function of two variables. We applied the chain rule. So what would the n variable case be? So the n variable case would be, it's simple, let's say the n variable case, it's just I equals 1 to n delta f delta xi delta, this is not partial, this is an important thing to remember. Yes, this is the n variable case. If you have a 3 variable, 4 variable, not a problem. If you have like x, y, z, just apply this. This is the general case or the n variable case formula for and of chain rule of partial derivatives. Thank you.